In these last several examples, we're going to have to do some heavy lifting with algebra to be able to perform integration. So for these first two examples at the bottom of the page, we have a situation where we have a fraction as our integrand. The numerator has multiple terms. It doesn't really matter whether or not the denominator has multiple terms. In fact, in the first example, it does not. So when this is the case, we should break up the fraction and then integrate each piece separately. So let's see what that looks like. So for my first example, to break up the fraction, I could split the terms in the numerator, not the denominator. So I could rewrite this as the integral of 2x over the square root of 1 minus x squared minus 1 over the square root of 1 minus x squared. And we could take that a step further and really break that into two completely different integrals, which I sometimes do if I have to do like u substitution for one and I don't need u substitution for the other. Just so that I don't catch myself making like a linkage error or I leave something in terms of x, something in terms of u. Okay, so let's deal with that first, the first integral expression. So I'm just going to go ahead and highlight this in blue. So if I integrate that, I think this is a good problem where we could probably just do u substitution. And even though the denominator probably makes me think of arc sine or inverse sine, I notice that I have an x in my numerator. So if I do u substitution on 1 minus x squared, I'm going to get a linear dx, or sorry, a linear du. So here's what I mean. Let's let u be 1 minus x squared. So du would be negative 2x dx. So I have a 2x, I just need it to be negative, which means I could multiply by negative 1 both in and outside of my expression. So now if I rewrite this, I've got a negative times the negative 2x in the numerator is going to get absorbed in the du, and then I would have the square root of u in my denominator. So that's probably most helpful to write as u to the negative 1/2 power du. So now if I integrate that, I know I'm going to add 1 to my exponent, so negative 1/2 becomes positive 1/2. Divide by my new exponent, or maybe multiply by its reciprocal. And since this is an indefinite integral, I need to give it a plus c. Since I'm going to be working with two integrals, I don't want c to be the same thing. So I'm just going to say like a c sub 1. And that just means it's the first constant in integration. We're going to have a second one. Okay, so as I finally write my expression, my final way that I would write this is negative 2 times the square root of, and then we'll do our u substitution. We said u is 1 minus x squared. And I'm going to say plus c sub 1. All right, so all of that work just there was just for that part of our expression that is highlighted in blue. These are super fun, huh? All right, let's look at the second term in this expression, which I'm going to highlight in green. Okay, so I'm going to keep the negative out front, and hopefully this one jumps out to me as arc sine. So the way I can tell this one works with, this one I can use arc sine and the first one I cannot, is I'm never going to have an x in my numerator like in that blue term. So now I'm going to use arc sine because I have a constant in my numerator and the square root of 1 minus x squared in my denominator. So this just becomes negative arc sine of x. And again, we would say plus c, but I'm just going to say c sub 2. And again, all that really means is that it's a different constant, like we're not referring to the same constant of integration. But it's not really going to matter because when we put these two together, we're just going to have a single c. So now, if I combine those two pieces, my final answer is negative 2 times the square root of 1 minus x squared. I'm not going to say plus c sub 1 there, but then I'm going to subtract arc sine of x and then just a plus c at the end. And that is our final antiderivative. And if this were a free response, I'd want to make sure to go back and put this in the equal sign afterwards. All right, let's look at the next example. So this next one is similar in that I have multiple terms in my numerator. So again, the first thing I'm going to do is break this up. X over x squared plus 4 dx. I'm just going to do 2 off the bat. Minus 5 on top, x squared plus 4 dx. So again, in this first term, I notice that I've got an x squared on bottom and x on top. That's going to make me think u subs. So I'm going to try u equals x squared plus 4. So du would be 2x dx. So if I need a 2 in my integrand, I could just put that 1/2 out front. So now I've got 1/2. The 2x gets absorbed in the du. The whole denominator is u. Oh, look at that. It's my favorite integrand, 1 over u. My favorite antiderivative. That's how you know I'm a math teacher, that I have a favorite antiderivative. All right, just like before, I'm going to use just like a C sub 1 just to indicate that this is a constant of integration. And I'm going to resubstitute x squared plus 4 for u. All right, so again, all of that work is just for that first part of our expression. So now let's look at the second part. I'm going to pop that -5, like I'm going to keep the negative. I'm going to pull the 5 out front since that's a constant multiplier. And I've got 1 over x squared plus 4 now in my integrand. Oops, that's supposed to be a plus 4. So hopefully this jumps out to us as being arctan, because a u sub won't work here. I can't let x squared plus 4 be a u sub because my du would have an x in it. So I might think of this as like an a sub, that if a squared is 4, a is 2, so that -5 is going to come along for the ride. When my antiderivative is arctan, I know I've got to have 1 over a out front, so 1 over 2 in this case, times the arctan of x over a, so x over 2, plus c, and I'm just going to call that c sub 2. Again, just to denote a constant of integration, not necessarily equal to the original one. We would need more information. All right, so again, our final answer, putting this all together, I'm just going to end up with a single c, because some constant we don't know, plus some other constant we don't know. It's just a constant that we don't know. So that's why we can just call this c in the end. All right, so final answer, that the original expression to which we were evaluating, that was bad grammar, of which we're evaluating this expression. We're going to get 1/2 natural log absolute value of x squared plus 4 minus, I'm going to do 5 times 1/2, which is 5/2, arctan of x over 2, all of that plus c. So that is our final answer.